Hi, welcome to the second half of Chapter 5, Sensation and Perception. Today, you'll hear me talk about hearing, the making of our ear and how we transmit hearing or noise to our brain. We will also talk about, in 5.5, other senses such as touch and taste. In 5.6, we will be talking about Gestalt principles of perception. And that has to do a lot with vision and space and how we view things. So we're going to talk about the ear and the workings of the ear. The ear is made up of three parts. It's the outer ear, the middle ear, and the inner ear. When we hear a noise, this noise travels from the outer ear, that's the part you can touch, to our eardrum, which causes it to vibrate. This vibration is transmitted to the ossicles. That's also made up of three parts. It's actually the smallest bones in the human body. Those are called the malleus, the incus, and the stapes. These vibrate and cause the fluid in your middle ear to move, and this movement is transmitted to the cochlea. Inside the cochlea, we have 15 to 20,000 hair cells. The hair cells then detect this vibration, and this generates nerve impulses that sends signals to the brain via the auditory nerve. Section 5.3 also talks about pitch perception, sound localization, and hearing loss. With pitch perception, this breaks it down into two theories, but there are several theories. The two theories that the book talks about, it's temporal theory and place theory. Really, both just deal with frequency, high frequency, low frequency, or high-pitched sounds and low-pitched sounds, and how the frequency hits the basilar membrane, and how we discriminate those sounds. With sound localization, it's just like our eyes. We can use one ear or both ears to hear, and if the sound is on our right side, the sound is going to hit our right side first, and be louder in our right ear than in our left ear, so we know it came from our right side. We can use both ears to know if the sound came from up or down, left or right. And then with hearing loss. Hearing loss is broken down into two basic categories. Conduction is anything that stops hearing from the outer ear to the middle ear, meaning earwax, a ripped eardrum, the bones malfunctioning. And this is usually resolved by the doctor. And then there's sensory neural hearing, and that's 90% of hearing loss, and it's destruction of the hair cells. And so this is, like I said, it makes up about 90% of hearing loss, and it is because of age, genetics, or the continuous hearing or listening to loud noises. So like my dad was in the Air Force and he didn't wear his headphones, and so now he has a cochlear implant, because this type of hearing loss it's irreversible, and so a lot of people use hearing aids or cochlear implants to help with this type of hearing loss. During this recording, we are going to combine smell and taste. So smell and taste, they are categorized as chemoreceptors. They are sensory cells translating chemical stimuli into action potentials that our nervous system can make sense of. And so let's talk about smell first. Well, smell and taste actually are most heightened at birth. and then they diminish as our life goes on. A newborn baby, studies show that a newborn baby can actually smell their mother's breast milk from across the room. And they can taste the difference between their mother's breast milk and a donor breast milk. So our sense of smell and taste are heightened at birth. Now, with that said, let's talk about smell. Our smell, it can bring back memories. It can make us feel hungry when we just ate. It can bring us happiness. It can make us sad. I don't know if y'all have seen the movie Someone Like You with Ashley Judd and Hugh Jackman, but she went to the doctor because her and her boyfriend broke up and she was all sad, and she went to the doctor and asked her doctor to have her olfactory epithelium removed, and that is the part of your smelling system that sends the stimuli to your brain. And so she asked the doctor to remove it because she didn't want to smell her ex-boyfriend's clothes anymore because it made her sad. So that's some fun stuff about your smells. But smells can, like I said, it can also make you happy. And so fresh cut grass, you can smell the rain before it comes. These are happy scents. With food, your sense of taste is definitely tied into your sense of smell. And so when you smell that pizza that's cooking in the oven, your taste buds are already starting to come alive. Before the 1970s, I know that I wasn't even born in the 1970s, but before the 1970s, there was a study that shows your tongue is divided up into 4, sour, sweet, something else and something else. But like you could only taste sour on the tip of your tongue and only taste sweet on the sides of your tongue. And that has been since proven wrong. It's kind of silly actually to think that they thought that. But they don't think that anymore. Now, with a diminished palate, either your smelling or your taste buds, when people lose the ability to smell or taste, this is tied to a depression. Studies show that when you can't smell and you can't taste, you lose some joy because a lot of people like the way their husband smells or their partner smells, and some people like the way that pizza smells. And when they lose this, they do fall into a depression. So that is smell and taste. All right, touch is very important for our fight or flight and for our survival. Pain, it's the nociception, and temperature is thermoception. With pain, it tells us when we need to stop and run away or stop what we're doing. If we are exercising and something starts to hurt, we know that we need to stop and reevaluate what we're doing. With temperature, we know when we need to add a layer of clothes or when we need to, again, like when we're working out, when we need to remove our sweatshirt. These are very important senses for our survival. All right, touch is very important for our fight or flight and for our survival. Pain, it's the nociception, and temperature is thermoception. With pain, it tells us when we need to stop and run away or stop what we're doing. If we are exercising and something starts to hurt, we know that we need to stop and reevaluate what we're doing. With temperature, we know when we need to add a layer of clothes or when we need to, again, like when we're working out, when we need to remove our sweatshirt. These are very important senses for our survival. This system is located outside of the cochlea in the inner ear. This is the system that maintains our balance and our body posture. When we are on, like if we go to a carnival and we happen upon a tilt-a-whirl or something that spins us around and around and around, this is the system that affects. This is the reason we get off and we either throw up or we fall down. And it's because of the system, everything is discombobulated in it once we start spinning. People that suffer from vertigo, this is the system that vertigo attacks. That's why people with vertigo, they get dizzy. You will see them fall down sometimes. And this is the reason why. Vertigo attacks this system, and this system makes you dizzy or can make you fall down. In Gestalt's principles of perception, we have the 5 main ones. It's figure grounded, proximity, similarity, continuity, and closure. But the principles of perception, this is to seek to explain why we perceive the things the way we do. Okay? And so figure grounded, in this example, the background, the grounded part, are the faces. It's the black part, the background. And the vase that you see, the white part, it's the figure. And we've all seen the old lady that looks like a young lady. If you need more examples. Proximity, when we look at this other example where it says A and B, we think all of A goes together, and then B, that when we separate it, that each section goes together, because if they're close, they must go together. Similarity is very similar. If they all have the same colored jerseys on, they must go together. With continuity, that X shape, we just think that it's going to continue. And closure, we don't need to see the lines to know that that is an oval and that is a rectangle. We know it, and that's how we perceive it. It's really not an oval and it's really not a rectangle. But when we look at it, we close the figure.